Hello everyone. So today we're going to look into the problem that is very popular problem for binary search tree. So the problem is find a successor for a node in binary search tree, and we're going to look into the brute force approach today. Okay. So let's quickly draw one binary search tree. So we got, let's say, 10. This one is 9, 6, 4. Okay, and then this should be, let's say, 12. So it doesn't matter, like it can be anything. And this should be 13, the 7, and let's say 5. And oh, sorry. So this should be 5. And then so this one, let's say we got 15. We got 20, we got 30, so it doesn't matter. So what do you mean by the successor of a node in a binary search tree? So the first thing you need to know is about the in order traversal of binary search tree, and then from there we just find the input node, and then the successor will be the next node of the input node. Right. So if you don't know the in-order traversal, so let's I'll just quickly run you through the in-order traversal, how it will work. So let's say in-order traversal traversal equal to, so in order traversal, what we'll do is we go all the way to left, down to the left, and then we visit node, we go all the way to right. Okay, so that means here, so we start from here, we go all the way down to 4, node 4, right? And then from 4 there is nothing, so we visit 4, right? And then we visit and we go right. There is nothing on the right side, so we back up, we go to 6, right? We already went to left, so now we have to visit 6, and then from 6 we already visited 6, so we will go to right, so the right is 7, right? And then from here we try to go to left, there is nothing, so we just visit 7, and we finish 7, right? We visit 7, we want to go to right, and then we want to go to left, but there is nothing in the left, we visit 5. Now we just back up, so this one is done, this one is done, 6 is done, we go to 9, right? So in 9 we have already gone to all the left nodes, so now what we do is we just visit 9, right? And then we'll go right, we go to the left, visit 13, we back, we already went to left, now we have to visit 12, so there is nothing in the right, we go back, so 9 is already done, we go back to 10, all the left nodes are done, so all the lefts are done. So what we have to do is we visit 10, and then we go to the right, so from here we go to the left, so we try to go to the left, there is nothing, so we have to visit 20, so for 15, and then we go back, we already went to left, we have to visit 15, and now we go to the right, so there is nothing on the left, so we visit 3, and then that's it. So if your question says find a successor of node 10 or find a successor of node 15, so what will be the successor of node 10? So the successor of node 10 will be the next node in order traversal array. So the next node of 10 is 20. So this will be the successor of node 10, and that's what we have to return. So if they say what is the successor of 15, then we have to return 3. But what will be the successor of 3? This doesn't have any successor because this is the last element, so we just return null, right? So this is the brute force approach. So let's dive into the code. All right, hey guys, so this code will run in O of n time complexity and O of n space, where n is the total number of nodes in the tree, right? Because like we basically have to go through all the nodes of the tree, and also we have to keep track of our inode or traversal array. So let's write code for this one. So what we want to do is we just want to we basically want to just generate this array, right? First we have to generate this array. We have to go through the inode traversal, and then we just generate this array, and after we finish generating this array, we just find the index of the input node, and we'll just return the next node. Okay, so for that, first let in order traversal array equal to empty array. Just let's first initialize the array, and then what we'll do is we'll just call this function in order traversal, and what we do is we pass the tree, and we have to populate this array, right? So in order traversal, what I said was first we go to the left and visit node and right. Okay, we'll do the same in inside this function. We'll just go recursively. So but the base we have to handle the base case in the recursive function. So if node is equal to null, or we can in JavaScript just if node if it is a falsy, then we just return. We don't have to do anything. Otherwise we go to the left. So we'll just call this the same function recursively, and then we go to left. We have to pass inode array, and then the next time is we have to visit the node, right? So visiting means we just populate our inode array dot push node, and then after we visit we go to right in order traversal, and then node dot right, and then we have to pass in order array as well. So what we did on this function was we just basically loop through recursively gone through all of these elements, and then just populate this inode traversal. So now this one is already populated. So what we do is we go back into the other function here. So now this is ready, this array is ready. Now what we do is we'll just so this is our input node, and then so we just need to find the next node, right? So what it is found index equal to, we just find the index where this node exists in this array. So for that one, what we have to do is in order traversal array dot find index, and then so this is basically the node, and then n dot value equal to node dot value. So this will give us the index of this node, but we don't want to return this node. We have to return the next node. But another one is we have to handle the special cases, like what will happen like if it is the last element, because if it is the last element of array, then the next there will be no any next node. So we have to handle that case. uh, if also you can ask to your interviewer, right, like if what will happen, like if node doesn't exist in in this tree. So you have to, this is the question you have to ask to your interviewer. But let's handle that case as well. Okay, so if found index equal to -1, that means the node doesn't exist, or found index is equal to in order traversal array dot length -1. So if this is the last index, so in that case we return null, otherwise we return in order traversal array found index plus 1. So we're just returning the next index, whatever this index is in, whatever this node is in, we just returning the next node in that array. So this algorithm will run in OF and time complexity, and then because we have to keep track of this array, and then it will just take OF and space. Alright, that's it. Hope this one was helpful.